Welcome to Unit 3. So this unit is a kind of a short unit. We're talking about triangles. We'll start with Unit 1 or Section 1, which is Basic Triangle Properties. And then when we get to 3.2, we'll talk about similar triangles. So first, let's do a quick review of how we can classify triangles. We can classify triangles by their sides. So for example, scaling is a triangle that has a different side. Each side is different, okay? So there's none of the sides are the same. All right, so for an example of that, we could do maybe something that was like that long, and then something that's kind of like this long, and then that is the longest side. Okay, this could be like a scaling. All right, next, isosceles. So for isosceles, we have two sides that are the same length, but the third is not. All right, so for when we write down and we have two sides that are the same, another word for that they're equal is the word congruent. All right, and to classify or to mark that they are the same, we will use these little hatches to say that they're the same, that they're congruent. All right, equilateral. Equilateral, all three sides are congruent, okay, and would put those little ticks or whatever on those to say that each of those sides are the same length. All right, with angles, we can classify them by angles. So acute is where all the angles are less than 90, okay? So for example, an equilateral is always also acute. Okay, so we look at these angles, all angles are less than 90. Okay, obtuse is where we have one of the angles is greater than 90. All right, so this angle, the top angle, this would maybe be like, I don't know, 140 degrees, okay, or something like that. And that would be greater than 90, and so we'd be able to say it's obtuse. So we just need to make sure that one of the angles is obtuse. Okay, you actually can't get more than one angle that is greater than 90. Okay, next we have a right angle. So right angle means that one of the angles is 90 degrees. And how to signify that, we do this little box in the corner. Okay, so that would be a right angle. All right, so let's see if we can classify some of these triangles. If you can, pause whenever you can and do it yourself. See if you can do it. All right, so this first one, since we have two sides that are the same length, aka an isosceles. Okay, so we'd write down isosceles. Okay, I spelled that right. Yep, isosceles. Okay, and then by classifying by its angle. All right, we don't have anything saying what the angles are, but to me, this angle at the top is more than 90 degrees. So I would probably say obtuse. Okay, all right. Next we have B. So we look at that. The first thing I notice is this 90 degree, which means it's a right angle, or a right triangle. Okay, and then if we look at the sides, since there aren't any of those tick marks, kind of like here, we know that it is scaling. Okay, scaling is that none of the sides are the same length. And if any of them are the same, then they will always have those little ticks. Like for example, C. C has 3. They have a tick on all 3 sides, meaning that all 3 sides are the same. They're all congruent. All right, and if we look at that, equilateral is it when we have all 3 sides that are congruent. So we'd say equilateral. Okay, and then by the angles, we kind of talked about this before. Since or with equilateral triangles, all of these angles will be less than 90, so it is acute. All right, D, we don't have any ticks saying that any of the sides are the same, so this would be scalene. Okay, and then for the angles, I don't see any 90 degrees, and I don't see anything that's greater than 90, so I would say this would be acute. All right, so let's look at E through H. So these are all a little different because they actually give us values. So here we need to look at the values and say, well, if we're looking at the lengths of the sides, let's see if any of them are the same. So we'd look and notice that we have 4.8 and 4.8, but the other side is not 4.8. So we have two sides that are the same. Two sides are congruent. So we would know that it would be an isosceles. Isosceles. Okay, two sides are congruent. And then let's look at the angles. All right, well here I notice that we have a 90 degree, so that must be a right angle. Or right, it is a right angle, but it is also a right triangle. Okay? So whenever we do these problems, you'll always have two things. One word for the sides, okay, how many of those are congruent or the same, and how many of them are acute, obtuse, or right angles. All right, F, notice here we have sides, all three sides, okay, and we also have all three angles. Okay, whenever you have an equilateral triangle like this, all of the angles will be also congruent. So here we'd say equilateral. And then classifying it by the angles, since they're all less than 90, we would say it would be acute. G, okay, let's look at those. All of the sides are all different, so I would say it would be scalene. And then looking at the angles, we have one that is greater than 90, so it would be an obtuse triangle. And then H, last one, we'll compare our sides. So all of these sides are different, so it would be scalene again. And then by angles, looks like all of these angles are less than 90, so it would be acute. All right, so that is classifying triangles. Hopefully that kind of made sense. This is just kind of, some of these things are just kind of have to memorize what scaling isosceles and equilateral means, what it stands for, or what it's, okay? And same as acute, obtuse, and right. All right? If you have any questions, let me know. All right, next we talk about how the sum of the angles of a triangle is always 180 degrees. Always. Okay? So if we add them together, so oftentimes when we write down like the length of, or like an angle, like its value, we would write it as the measure, that's what the M stands for, measure of angle A, plus measure angle B, and the measure of angle C. All of those measures, if we add them together, gives us 180. Okay, so we can use that when we're trying to solve some of these equations or problems. All right, so it says find the measure of each angle. All right, so we have two of the three angles. We have 49 degrees plus 72 degrees plus a question mark. Okay, let's just call that question mark X. That's what we're going to solve for. Add those all together, we'd have 180 degrees. And in Unit 2, we talked about solving equations, 1-2-step equations or multi-step equations. Okay, so what we'll do, and I mean there's different orders of solving these problems. As long as you feel like you are understanding what's going on, it'll be just fine. So, if you wanted to, one of the things we talked about in Unit 2 is we said we would always combine like terms on the left side, and we'll combine like terms on the right side. So if we combine those together, we'd end up getting 49 plus 72, and that would give us 121 plus x equals 180. Okay? Now if we want to have x by itself, all we need to do is subtract 121 from both sides. Okay, 121 subtracted 121, that cancels, that gives us 0. All we'll have is x equals, and if you can use your calculator, that would be great. 180 minus 121 gives us 59 degrees, and that would be your answer. Okay? All right, if you want to double check, you can always check by adding all of the angles. So you could do 59 plus 49 plus 72, and that will end up giving us 180. So that can kind of check your problem, make sure you've got it right. All right, so this is probably the most basic solving problem that we have for triangles. And we'll have some where it's a little more involved, but not too much more. Okay, so here's another example. Please pause and see if you can do B, C, and D. So again, we'll do 20 degrees plus 130 degrees plus x is equal to 180 degrees. So we'll combine like terms on the left side. That gives us 150 degrees plus x equals 180 degrees. Then we'll subtract 150 from both sides. That would cancel and end up getting x equals 30 degrees. C, same thing, would do 50 degrees. Remember, if we have this little box in the corner, that tells us it's a 90 degree. So we'll add that to 90 degrees. We'll add x. We'll have this question mark be x. And that will all add up to give us 180 degrees. Combine like terms on the left, that gives us 140 degrees plus x equals 180 degrees. And then we'll just subtract 140 on both sides. Would end up getting x equals 40 degrees. Okay, so you just evaluate that using your calculator or just use it in your head. Okay, and then the last one, we have a D. So we could ask this isn't what it's asking for, but what type of triangle that is. Well, since we have two angles that are the same, okay, I don't know if I talked about that before, let's see. No, we didn't really talk about that. So let's just ignore that for now. But still, we're going to do the same thing. We'll do 70 plus 70 plus x equals 180. So add those together. It gives us 140 plus x equals 180. Actually, it turns out to be exactly the same. So subtract 140, and we get x equals 40 degrees. Okay, I know you can just kind of look at that and say, oh, well, triangle's 180, so I'm just going to subtract 70. I'm going to subtract 70, and that's my answer. Okay, but things are going to get a little more complicated, so please don't make shortcuts. Just do show all your work. Okay, so for example, E through H, we have some sort of different type of problems where we have x plus would be our angle, and things can get a little more complicated. So please, like I said, don't do shortcuts because you'll perhaps make mistakes. So we'll do the same thing though. We'll do 50 degrees plus 70 degrees plus x plus 66 degrees equals 180. So we'll combine like terms. These are like terms, that's like terms, and that's like terms. That ends up giving us 50 plus 70 is 120, and then add that to 66 gives us 186 degrees plus x equals 180. Okay, and then we'll just subtract 186 from both sides, and we'd end up getting x equals negative 6 degrees. Okay, so we can double check, we can come look at that and say, well, if this is negative 6, then this whole angle is 60 degrees. And if we add 60 plus 50, that's 110, plus 70, that gives us 180, and that works out just perfect. All right, so next problem, F. Same situation, we'll just add all angles, so that gives 57 plus x plus 40 plus 90. So remember, this right angle tells us the 90 degrees equals 180. Combine like terms. Okay, that will give us 187, I think. Yes, 187 plus x equals 180. We'll subtract 187 from both sides, and would end up getting x equals negative 7. Okay? And if you want to check, we could plug it in. This would be a negative 7. Would end up getting 50 plus 40, which is 90, plus 90 is 180. G, same sort of setup, okay? We'll do 80 degrees plus 52 plus x plus 52 equals 180. Combine like terms, so those are like terms, that's like terms. That would give us 184 by adding all of those. And then if we combine the variables, so x and x, that would give us 2x equals 180. All right, then we'll subtract 184 from both sides. Okay, so remember it's kind of like opposite PEMDAS, so we'll do addition and subtraction first. We'll have 2x equals negative 4, and then we divide both sides by 2. End up getting x equals negative 2. Okay, and then things get a little different now that we have, like all of these, we just kind of x's by themselves. So let's look at a problem where we have some sort of multiplication by our variable. Okay, so we do the same sort of thing. We do 7x plus 8 plus 7x minus 2 plus 90. Okay, remember this is 90 equals 180. And then we'll combine like terms. So let's maybe combine the ones that have the variables. That ends up giving us 14x. And then we'll combine all of the constants. So 8 minus 2 gives us 6. And 6 plus 90 gives us 96 equals 180. Okay. And then we could subtract 96. Both sides would end up getting 84 equals 14x. Okay, and then we'll just divide both sides by 14. And you'd end up getting x equals, we use our calculator, and we get 6. Okay, so that is solving for angles or for x, depending on what they're asking for. If you have any questions for that, let me know. Okay, let's go to some conjectures. Okay, these are kind of like proofs, things that have been proven that always works. Okay, so triangle inequality conjecture. All right, the sum of the lengths of any two sides of a triangle, so it doesn't matter which sides. So like say if this was 1, or actually let's do 1, 2, and 3 or something like, no, I can't do 3. Let's do a 2, 4, and a 5. Okay? Sorry, I kind of messed that up. 2, 4, and a 5. Okay? Or no, 2, 3, and 5. Let's do 2, 3, and 5. Sorry, I'm kind of changing my mind. Okay? So, no, that wouldn't work either. 2, 3, 4. All right, so something like that. Anyways, so if we add these two sides, we'd get 2 plus 3, which gives us 5. And the thing says that the sum of the length of any two sides of a triangle is greater than the length of the third side. So we want to compare that to the other side. So 5 is greater than 4. Check. Okay, next we try maybe these two sides. 3 plus 4, which is equal to 7, is 7 greater than the other side, which is 2? Check. And then we'd check the very last one. We'd add these two together. 2 plus 4 equals 6, and 6 is greater than 3. Okay, so we just use this conjecture to ensure that that is actually, we can make a triangle with those sides. An example of where it wouldn't work is, say we had some sort of side that is 10, and we had two other sides of our triangles that were only 1. Okay, there's no way you could ever make a triangle with that. They'd never be able to, these 2 points would never be able to touch. They're not long enough to be able to make a triangle. All right, so the shortcut is, instead of having to do it for all 3 sides, okay, adding them together, we can use the sum of the smallest 2 sides. It has to be greater than the largest side. Okay, so here they want us to state if the 3 numbers can make a triangle. So we just want to say yes or no. So we're going to add the 2 smallest sides. That gives us 14. And is 14 greater than 12? Yes, so that could make a triangle. Let's do an example where it wouldn't. So if we added the 2 smallest, that gives us 20. Is 20 greater than 22? Would say no. Okay, 20 is not greater than 22, so that would not be able to make up a triangle. The 2 shortest sides wouldn't be long enough to touch to make that triangle. All right, next, 2 smallest, 10 and 7. That gives us 17. Is 17 greater than 17? Okay, and this would be no. That would be false. So this would also be no. Okay, what would happen here is if this was 17, okay, one of the sides would be 10. Let's see if we can kind of get it about the right length. And the other side would be 7. So instead of making a triangle, it would just make a straight line. All right, there wouldn't be any area to calculate for a triangle. It would just be a straight line. So it has to be greater than, not just equal. It has to be greater than. All right, next 2 small ones. So pause if you haven't yet. Pause and see if you can do D, E, and F. Add those together, that gives us 20. Is 20 greater than 19? We'd say yes, that would make a triangle. E, add these 2 together, that gives us 12. Is 12 greater than 12? That would be no. And then last but not least, 4 plus 3, that gives us 7. Is 7 greater than 9? And that would be no. That would be false as well. All right, so just add the 2 smallest sides, and they have to be greater than the third side. All right, okay. The other conjecture we have is the side angle inequality. All right, so this conjecture says that the shortest side of a triangle, so let's come up with some sort of triangle, maybe some triangle that's kind of like this. going to do a little, yeah, anyways, so let's come up with that triangle, okay? It says the smallest side of a triangle, so the smallest side for that triangle would be like right here. It says the smallest side of the triangle is always opposite of the smallest angle. Okay, so opposite of that side would be this angle. And this would be the smallest. Perhaps that's like 10 degrees. This would be 90, and this would be 80. All right, so just remember, just across from that side is always going to be the smallest. So if we're doing the smallest side to the, across that would be the smallest angle. If it was the largest side, then across that would be the largest angle. Okay, so looking at this example, the longest side, I changed my color, this would be our longest side, and the longest, or the largest angle would be 90 degrees. Okay, so those are across from each other. All right, so let's do some of these problems. 6. So we want to first, it says, order the sides of the following triangles from smallest to largest. So we want to list them in order of their smallest and largest of their sides. So we'd start with the smallest angle. So this is the smallest angle, which is 30, and we'd go across the opposite side of that angle would be this side. This would be the shortest side. So the shortest side would be LM. The next smallest angle would be the 49, would go across, and this would be our medium length side, which would be MN. And then the largest angle, which is right here, 101, would go across there, and that would be our longest side. So we just go across from that angle, which would be LN. All right? So let's do some more examples. I'll do B, and pause if you can to do C and D. Okay, so smallest angle across from there would be our smallest side, so UW. Next, we would have our next largest would be 55, so the medium length would be LU. Okay, and this is just the way we write like a line segment, part of a line. Okay, would go from V to U, or you could do it U to V, either way. And then the largest angle, which would be 85, would go across, and this would be the largest length. So we'd have VW. Okay, so pause if you can do these ones, and come back to me. All right, so smallest, 45. So we'd have CE. After that, we would have the next largest would be 54. We'd go across CD. And then the last one would be 83. So the longest side would be ED. Okay, D, smallest, is 54. But wait, we have two that are the same. These would be equivalent. So this side would be the same length as this side. So we'd say AC is equal to or congruent to BC, and then the largest side would be across from the largest angle, which would be AB. Okay? All right, so let's look at some. This is kind of like doing the opposite. So here, we're going to skip this one. I don't think that's supposed to be there. Okay, so we have all of the sides. Now we want to list the angles from smallest to largest. So the smallest side would be 15. Across from there would be angle X, angle X. The next largest angle would be across from the next largest, 17. The next largest would be angle W. And then the largest side, which is 21, would be opposite of angle Y. Okay, so these are just your answers. You can box those, would be great. Okay, see if you can pause and do G and H. All right, so smallest, angle Q. Next, angle S. Next, angle R. H, smallest. Across from there would be angle V. All right, and these ones are the same length, so that the angle must also be the same length. So we'd say angle U is equal to angle W. All right, so hopefully you feel good about that. If you have questions, let me know. Last page, we're going to talk about properties of isosceles triangles and equilateral triangles. So, it says two sides of a triangle are congruent. Okay, congruent basically means the same as equal. So two sides of the triangle are congruent. Then the angles opposite of those sides are also congruent. So here we have these congruent sides. We go opposite of there, these angles are also congruent. Okay? And if you, we're going to have problems like that where you'll have to realize that to be able to solve an angle or a side. Okay? This just says that basically the opposite. If you have two angles that are congruent, then their opposite sides must be also congruent. Okay? Properties of equilateral triangles. Okay, so equilateral triangles tells us that all three sides are congruent, but this tells us that if a triangle is equilateral, then the triangle is also equiangular. Okay, so their angles are also congruent, all three of them. And vice versa, if you have a triangle that is equiangular, then it is also equilateral. So if all the angles are the same, then we can know that the sides are also the same length. All right, so let's use those properties to solve these types of problems. Okay, so looking at E, since we have two sides that are congruent, we can look at that and say, oh, well, that is an isosceles. And it tells us that if we have two sides of a triangle are congruent, then the angles are also congruent. Those angles opposite of those sides. So opposite of this side would be the 33, and this angle must also be 33. Okay? So we're just trying to find out what this angle is at the top of the triangle. So we would do 33 plus 33 plus x is equal to 180. This would be the same thing as 66 plus x equals 180. And then we could subtract 66 from both sides and would end up getting x equals 114, okay, degrees. All right, F, same sort of thing. We have all three sides are congruent, so that's an equilateral, meaning that all three angles are also congruent. So X must also be 60 degrees. Since this is 60, this is 60. And with equilateral, the angles will always be 60, okay? Because if they're always the same angle, and triangles add up to give us 180, it makes sense that we have 60 plus 60 plus 60 is 180. All right, G, okay, this is an isosceles. We have two angles that are congruent, so that means that their opposite sides are also congruent. So basically, x is also equal to 12. Okay? And then h, all three angles are congruent, so all three sides must also be congruent. This is an equilateral triangle, so we'd have x equals 8. All right? So if you have any questions, please let me know. Thumbs up if you watched this video and if it helped you. All right? Thanks.